In this video I'm looking at structural forms and the hyperbolic paraboloid, but this time as a surface translation rather than a straight line element as a doubly ruled surface. So what I have set up here is I'm going to be drawing the elevation and plan of it down here, and it's going to be based on an in view. So how this is formed is it's translating a parabola here along in a second parabola here. So it's the translation of an upright parabola along an inverted parabola. So what's going to happen is our parabola, this shape, is going to start here and it's going to move down along this way until it ends up down here. So we'll need to work out the width of that based on how much of it is still exposed above the horizontal plane here. So just for the setup for this question, the base of my parabola, which will be here on the left, is 100 mil. The height up is 80, and I have points A, B, and C. B being the vertex of the parabola. For the elevation, this distance B across here is 120, and the point where the parabola, this second parabola, is going to come down to is going to be at 40. So this is 40 and this is 40 up above. All of the dimensions down here will be determined by the stuff that we've already got up here. So I'm just going to start by drawing my parabola here on the left hand side. This is down to, I'm going to divide this up into a number of equal parts. So I can get 5 equal parts straightforward enough out of this. This is my axis running from B down here. The ones that are perpendicular to the axis, the ones that come out, that start on the line that's intersected by the axis, they are drawn parallel to the axis. And the ones on this side here, which are starting off parallel to the axis, end up joining to the vertex. So that's 80. So giving me 16 millimeters up on each of these. Each of these now are going to join to the vertex B. And labeling these, it's important that they have to be labeled just so that you get this done right. A here is going to be our 0, our starting point, and then it's 1, 2, 3, 4, working in. Same going the other way. 0 down here again, 1, 2, 3, and 4. Where the 1's cross each other, it's point, 2's cross, 3's cross, and 4's cross, and so on. Now what we can do is we draw the best curve that we can. That will join through all of these, and that gives me the left half of this. The right hand side of this is done the same way, so I'm just going to skip forward and do that now. So that's the end view, or the first part. It's not quite the end view, it's just the forming parabola, the parabola that would be translated along this one. So what I'm going to do next is we're going to set up the second parabola that we need to work with, and that's one going from B down to this point down here, with this point down here being our vertex. So our parabola is going to be inverted this time, so it's going to be coming down along this way. So I'm going to divide this section here up into a number of equal parts, and this 40 up as well also. So again, I'm going to use 5 equal parts. You can use whatever number of parts you like. And same going this way, in sections of 8 this time. Now, if this point down here was E is our vertex, this B shall be 0 this time. So I've got 1, 2, 3, 4, and 1, 2, 3, and 4. Now our axis would be the line going from E down along this way. So there would be the second half of this off over here. So E is our axis. So what I'm going to do is work on my rule. So the rule is if my points are on the line that is cut by the axis, they are drawn parallel to the axis. So this line here, that's where all those points are, that's cut by this axis. So those lines are drawn parallel to the axis. And the ones that are already parallel to the axis join to the vertex. So point 1, 2, 3, and 4 back down here to E. So drawing in the curve as best we can again. And that gives us the plan, or the elevation, sorry. So that gives us the elevation. So I can darken in this part of it because this is going to be the whole hyperbolic paraboloid. This entire area in the elevation is an enclosed surface. So it's this surface here. That's one entire surface there. So now what I need to do is I need to find this in plan, what it looks like in plan. So in elevation and in view, the curves that we see are based on parabolas. In the plan, they're going to be based on hyperbolas. So our construction is quite similar, but there's one change. So now we're going to look at the plan, and for the plan, this here is the full width of the parabola. So this is going to be our dark line. It's 100 mil wide. So at this point we're seeing the widest part of the parabola. We're seeing this full section of it. That's because it's at its highest point up here. But what's going to happen now is our parabola is up here. It's going to start moving down along this way, following along this piece. So as it's moving along, this top point B still slides along this line, but that's going to cause this part of it, the lower part of it, to disappear below our horizontal plane. So as this is moving down along, this is going to start getting narrower and narrower and narrower based on the width of this here. So when it's this tall, when it's 80 mil tall, it's 100 wide. If I was to go here or somewhere along here and say that it's now 60 mil tall, how wide is it at the 60 mil point? So I'd have to measure down here 60 mil and find the width of it at 60. Same at 40, so same at the 40 point over here. So how wide is my curve going to be at 40 height? So this is as much of it as that's exposed. So if I measure that height, the 40, that will tell me how wide this is going to be over here. So that's what I'm going to do. So this goes down here 40, this comes down to a height of 40 millimeters, starts at 80, comes down to 40. So what I'm going to do is I'm going to measure the width of this at 40. Now you always have to measure it from the top, because point B translates along this line here. So we're not measuring from the bottom, we're always measuring from the vertex down, and that's going to tell me how wide our parabola is going to be at that point. So if I'm to take this height here as a height, that is this height here. That is going to give me a width of the curve at that height. So that gives me this width here. So whatever that width is, that's how wide it's going to be at this point here. So I can use my compass to measure that distance either side of the axis. And that's how narrow this is going to get. So this is, our curve is going to start coming in this way, and it's going to come into this point. If I was to take another height, if I was to take, let's say 60. So if I was to measure the width at 60, so this is a height of 60 now, which the corresponding height at 60 is here. So that's at a height of 60. So how wide is the object going, how wide is my curve going to be at that point down here? It's going to be based on this width, so the distance from the center out to the side, and doubled. So our curve would go through this point here. If I was to take it at 50, let's say 50 is here somewhere, I'd measure down the 50, find the width of the object at 50, and that would give me the width of it down here. So that's one way of doing it. What we're going to do, because we found these 2 points here, this being point E, F and G, what I'm going to do is I'm going to find, as these are based on hyperbolas, going to find the curves here and here by drawing hyperbolas. So what we're going to do is we're going to divide this up into 5 equal parts, or number of equal parts. So I can use the same 5 that I had earlier on. So I'm just going to transfer them down. I also need to divide the sides up into 5 equal parts. Now the area that I divide up here is the area outside of G and F. So further away from the axis from G and F. So it's this area here, that much, and this much down here also need to be divided up. So I'm just going to mark off 5 equal sections. And again, following my normal construction for dividing up a line. And then need to go parallel to that. So point G is the vertex over here. These lines here on this side shall join to V, or to G, and these ones shall join to F. So I'm going to label the points first. 0, furthest away from the vertex, 1, 2, 3, 4, and I got 1, 2, 3, and 4 here also. So the ones on this side, as I said, join to the vertex, the near one. These join to the opposite vertex. So where the 1's cross, 2's cross, 3's cross, and 4's cross, find up there at the end. Joining all these up together. And that gives me my curve. Now if we look, the point that I marked here that it was at a height of 60, that's also on the curve here, so that point has passed through it. So I'm going to do the same thing here on the opposite side, so I'm just going to skip ahead into that. So I just jumped ahead there a small bit. Now we measured a height down here of 60, so this height, that corresponding height, what I'm looking at now is just showing that the distances here, the widths here, it's going to be the same here based on the height. So the height here is this same height, this height and this one. That gives me a corresponding width on the curve, which ends up being the same one here. If I was to take another random height here, so just taking a random height here, and I'll transfer this height across. So random height here, finding that height in this view. So measuring from the top down, from here top down, finding that height. That gives me a width on the curve, so it's just below this red line. So that's based on height coming down here. So that height there is equal to this width. And if I check that width down here now, directly below where it is in the elevation, I end up with the same width. So that gives me this point, and here also, so I end up with the same width. So finding a height here gives me a corresponding width in this view, which will end up being the same width as it is here. So this width here, this orange width, is the same as the orange width over here. So if I take any height here, transfer that height over to the end view, that is going to give me a corresponding width for the curve, and I can find the width of the curve down here. This is going to be very important for the next question that we look at. Same for the height of this one. That height here gives me a corresponding width for the curve, and that's going to be this point down here now. So that completes this video on drawing the hyperbolic paraboloid as a surface translation.